question about why one is more abstract or less abstract or more concrete or whatever than the other ones? Okay. So two of the questions dealt with that. What are the advantages of the instructional algorithm over the standard algorithm? Does everybody
You see your process easier? Is that what it
see your
means?
process easier?
It's more, instructional is more step by step. And it's done out of, so it's pretty much done out of tens. So it's faster to do the math. Powers of tens, so that'd be 300 times 6.
300 times 800 is, we've got,
Right. So it's
everybody
just
with
quicker
me?
to do
I'm
the
starting
math.
on the left. You don't have to start on the left with the instructional algorithm, but you can. Now what? 800 times
50.
50. How many zeros am I going to need?
3.
1, 2, 3, right? And now 8 times 5 is 40. 800 times 7 will have how many zeros?
2 zeros.
2 with a 56. Then I'm going to go the 90 times the 300. How many zeros?
3.
9 times 3 is 27. 90 times 50 gives, I need 2 zeros. Everybody know where I'm getting these zeros from? 9 times 5 is 90 times 7 is 1 0 with a 6, 3. Now we're going to take the 6 times the 300. So 2 zeros with 18. Then 6 times 50. And 6 times 7 is, then we just add them up. While we're at it, let's just use the scratch method.
How do you know how many zeros to put?
Who can answer that?
It's how many zeros to put?
Yep, how do you know?
Multiplication, sorry, to me it's very simple. It's
Well,
how many zeros are there?
so if I take
So if it's
800 times
50,
50.
it's 3 zeros.
how do you know it's 3 zeros?
It's multiples of 10.
How many digits there are behind the two numbers you're multiplying?
So there's 1 digit to the right and there's 2 digits, so that's a total of 3 digits. So I put 3 zeros and then I get my 40 and put it on. Okay. We're assuming that you've been doing all kinds of work with your students. By the time you get to a problem like this, you've been doing all kinds of work with your students so that they would say, take 20 times 3. Well, that's the same as 20 times 2, except what? Has a 0 out on the end, right? And then you'd have them do 20 times 300, or 200 times 3. And that's the same as 2 times 3 with 2 zeros. And then you would change it to do this. Well, that's going to be a 6 followed by 3 zeros. Does that make sense? All right, let's do the scratch method. 2, 7. Then if we're adding here 6 plus 5, I scratch because I got to 10. I'm just bringing the 1 forward. 1 plus 6 is 7. 7 plus 8 is 15. I scratch and bring the 5 forward. 5 plus 3 is 8. Okay. Now as I move to this next column, I'm going to take 2 scratches with me. 2 plus 5 is 7 plus 7 is 14. Bring the 4 forward with the other 4. It'd be 8, 9. I take 1 scratch to this one. We'll make it 9, 11. So I scratch, bring the 1 over here, and I get a 3. That should be our answer. That is doing it with instructional. Now let's do it with the standard. What are the advantages of the standard algorithm? Compact, efficient, but no understanding about why we're doing what we're doing unless you have done all this preparatory work with the concrete materials and then move to the instructional. So with this, I have to start on the right, correct? I can't. So 6 times 7 is 42. We write the 2 and bring the little 4 up here. 6 times 5 is 30 plus the 4 is 34. So I put a 4 here and put the 3 up here. 18 plus 3 is 21. Now, what do I do? Put a 0. By the way, I have seen teachers who teach put an X here to hold the place. It does the trick, but why put an X if it's really a 0? Don't use X's to hold places. So we're doing 9, right? 9 times 7 is 63. So I do this and I put a 6 up here. And here's where you're starting to see, now I go 9 times 5 is 45. Let's see, do I add the 4 or do I add the 6? Do you see the problem that students have? And some teachers say, well, always put it on the left and then add the one on the left. Yeah, some people say, cross out the other one when you write the new one. Some teachers teach, erase the first one and write the second one. Don't teach your students that. Why?
Because they can't go back if they make a mistake and tell where they made the mistake.
They can't go back and
you can't.
You as the teacher can't go back. You can't see what they've been doing. Does everybody follow what I'm saying? Teaching them to cross it out is probably the best way. And be consistent on the side you put it on. I like to put it on the left because we're moving towards the left. So now, where were we at? We had a 9 times 5 is 45, plus the 6 makes 51, so we put a 51. We cross this out. 9 times 3 is 27, plus 5 would be 32. Finally, put 2 zeros. We've got a 6 with a 5. 8 times 5 is 45. Put a 5, put our 4, and 8 times 3 is 24 plus 4 is 28. Now we should be able to get the same answer that we had over here, did we? Yes. Much more compact, but all of this stuff can be very confusing to students. If you do this, you'll be able to explain. What's this 5 right here? It's that 5 right there. Right? You see what I'm saying? You can actually look to see where those come from. And if you do a bunch of these before you move to that. We're modeling this class in what we want you to do, but we're not doing it in the timing. You would do a whole bunch of these problems before you ever got here. You'd do a whole bunch of concrete stuff, and you wouldn't do it with 3-digit by 3-digit. You'd start out with 1-digit by 1-digit, and then you'd go to, after you've done the concrete to abstract for the 1-digit, you'd move to 2-digit. You'd do a whole bunch of each of these steps in the. We've just kind of laid it out quickly. Does everybody understand what I'm trying to say? It's not. Don't teach your class at the same pace I'm teaching you. You have a much better background than they do. Okay. So, what were the advantages? It is more closely related to distributive property. You don't have to worry about carrying the digits to the top of the problem where they can get mixed up. It is not more compact. That's one of its disadvantages. Okay. What else while I was gone? You learned some new algorithms. What did you think of them? Cool. What was the coolest one? Chinese you liked?
Can you do an example of the Chinese one where there's like a lot of the lines? Because
I can't figure it out. Like, how do you prove them?
Do you want
The
to
intersections, how do you prove?
Jump up there.
somebody give me a number?
Do 3, 2, 1 times 4, 2, 3.
You take this first one, obviously, you just go 3, 2, 1, 4, 2, 3. 3 times 4 is what? 12. So this would be 12, and so forth.
Can you continue?
Continue?
Yeah,
Sorry.
continue.
Okay. So 4 times 2, 8.
Is this, I was gone, in your expert groups, is this what you decided to do? No.
Just lines and it was.
Okay.
Yeah, I wasn't here, but I
Oh.
did do the homework, and that was one of the things I enjoyed the most is YouTube. They showed
This way.
this way plus the other way. The guy was like, okay, here's the way to do it. You know, you do the lines, all the lines, and he's like, what if you have 1,000 and something times 1,000 and something? And this is the shortest way. So it's.
Can you
I mean,
Go ahead,
do it a
finish
little
yours.
nicer, though.
Finish yours.
Do it a little nicer so they can
4, 2, 1, 3, 2, 1, and
Does it matter which way the lines go?
Yes.
what do you mean? Why does it? How?
I don't know. I thought they may erase my lines.
So
if I do it.
3, this is your hundreds. When it's on the left side, you have to start with your 100 on the top. Because otherwise you completely mess up your order when you're reading left to right.
She's doing her 321 this way. I'm doing it this way.
Right, does it matter
No.
that way?
No,
Okay.
because multiplication is commutative anyway, right?
Right.
So, but what you need to have is on the left, leftmost is your largest digit, and then smaller as you go to the right for both numbers.
Okay.
Okay? So notice my 4 it's on the top, but it's to the left. So here, well, there's the, it's nice if you have colored pencils or whatever to, these curved lines aren't part of our problem. They're just helping us get the place values. So I start on the right and I write 3, 8, what? 7. Bring the 1 over here, making it a 5. Bring this one over, exchange it to here, making it a 3. And then that becomes a 2. That should be our answer, 235,783. Okay? Yeah.
Yeah, that's what I don't get. I don't understand how you group any of it. Like, why do you group it like that?
What you'll do is you'll take your first, if it's 3 times 3, we'll have one set of intersections, 2 sets, 3 sets, 2 sets, and 1 in the place values. So if you make it nice and symmetric, it's just the see, this is right above those, these 3 are right above each other. Okay?
Okay, so with the zeros.
Did anybody check out with a calculator? Did we get the right answer?
I should have one, not a 2 in the front.
Let's see, what did we do? We bring this over 5, 15, we bring the 1 over, making it a 3. Oh, but there's nothing, yeah. We brought that 1 over to there, yeah. That should, 135,000.
Yeah.
Question?
Okay, on your method, except there's 2 zeros, you have to draw lines to hold place height, or?
It helps. Don't have to. After you did a bunch of these, you'd get very good at just lining up those intersections. You don't have to draw them, but it does help. Any other questions? Can you do other bases with Chinese?
Yes.
Absolutely. Since all of my numbers are under 5, we could do this with base 5. If I quickly change this to 3, 2, 1 base 5 times 4, 2, 3 base 5, we're going to get a 3, but this 8 is going to be one group of 5 with 3 left over, right? This 17 is going to be 3 groups of 5 with 2 left over. 14 becomes 2 groups of 5 with 4 left over, and 12 becomes 2 groups of 5 with 2 left over. And now I would write, we'll do it up here, 3, 3, this 1 comes over here to 32, makes 33, which is 3. I bring the 3 over here, makes 27, that's 27 is 9 groups of 3. So we're going to take 9 groups of 3 with 0 left over, but those 9 here means I'm going to have 3 groups of 3 with 0 left over, so that's the same as 3, 0, 0, right? You follow me? So it works the
base
same way,
5.
but you what?
It's base 5, not 3.
Base 5, thanks. Boy. So, let's see, where were we at? 3. Base 5 was 1, 3. And what was there?
2, 1, 3, 3.
Was that a 32?
Yeah.
Should have changed it underneath. 17 wasn't it? 17. So if I bring the 1 group of 5 over here, I now have 18 groups of 5, which is 3 groups of 5 with 3 left over. And then I say, okay, so that's, wait a minute. So 3, and that 3, and then we're going to take this 3 over to here. What was this? 14. This was a 14. I'm going to bring the 3 over there, making 17. But 17 is 3 groups of 5 with 2 left over. So I'll write a 2 up here. And take this 3 over with the 22 makes 25. 25 is 5 groups of 5, which is 1 group of 5 and 0 left. That should be our answer in base 5.
I have a question. Is there any way we can do like a 3 by 2 instructional algorithm in another base? I have to get that on the board.
3-digit by 2-digit number in another base. Standard algorithm? Instructional algorithm. Let's do 6, 5, 4 times 3, 2, and let's put it in base 8. Who wants it? Instructional algorithm. Left to right. Thank you. Did everybody get some 2-color chips?
No.
Or did it get hung up? Get a small handful per pair and pass them around.
Kind of like that.
Yeah?
Okay.
Talk out loud.
Okay. I kind of lost my voice. So 2 times 4 is 8, and it's base 8. So we're gonna have to carry it over. So 8 written in base 8 would be 10, right? So there's the first one, and then 2 times 5 would be 10, and 10 written in base 8 would be 1, 2. So then you write it like that, and you have to put a 0 there because we've got 1 extra one there. Okay.
So far, so good.
2 times 6 is 12, so base 8 that would be
One group of 8 with 4 left over.
And then we have the 2 right here. Sorry. Okay, so now we have to do the 3. So 3 times 4 is 12, and that would be, let's see, so 3 times, so that'd be 14, right? And we only have 1 because we have this number right here. And then 3 times 5 is 15, and that written in base 8 would be 17. And then 3 times 6 is 18, and that written in base 8 would be 2.
How many zeros do we want?
3.
There'd be 3, but you have to move it over 1 because of the, if it goes to
Wouldn't
base
it
8.
be 2,
Oh,
2?
base 8, right? Yeah. Okay. So just 2 right there.
There's another 2 too.
There's
Because you have
2
2
twos.
groups.
Oh, right, sorry.
There's 2 2s, so 222. Or just 22. Yeah.
22. Okay, and then,
Let's just stop and make sure everybody understands what she's done so far. Anybody want to ask a question? Remember, this is remainder. We okay.
okay, and then you add it together. So you have 1, 2, 3, 4, 5, 6, 7. 6, that's 13, so that would be. So 13, written in base 8 would be 15, so you have 5 remaining, 13, so 5 remainder and then 1 up here. So 1, 2, 3, 4, 5. 1, 2.
Okay. We could quickly check this out by just grabbing a calculator, converting those to base 10 numbers, multiplying them with your calculator, and seeing if that base 8 number is equal to that base 10 number.
How do you change it to base 10 again? I'm sorry.
I would, in my calculator, type 4 times 1, 8 to the 0, plus 5 times 8 to the first, plus 6 times 8 to the second. That's what I would type in my calculator to get the base 10 equivalent. This one will what? 2 times 1 plus 3 times 8. So that's 24, 26. This is 6.
Somebody doing it back there.
Yeah, somebody got it?
That's 428.
428. Okay, now take 428 times 26.
11128.
11128. Okay, now,
It's an 8, not a 6.
did I say 8 and write 6? Okay, now what we want to do is we want to convert this to base 10, and hopefully it will be this answer. So we'll put 0 times 1 plus 7 times 8 plus 5 times 8 squared plus 5 times 8 cubed plus 2 times 8 to the 4th and hit enter, do you get this answer? Then we must have done our multiplication correctly. Okay?
Do we have any questions on what I did over here?
Yes.
Okay, so it's much easier if I color pen or something. Draw the lines, number them. I do a solid line and then I dot it to make sure I know where I'm at, because it distinguishes the two different lines. So you have 3 times 4, which is 12, so that's the section. And up here I divided this part right here, which is 2 times 4, which is 8, 3 times 2, 6, it's 14. So you can just continue through the whole process. So we've got 1, 2, 3, 4, 5 different sections. So with our first number we've got 12. So we write down 12, and we count how many digits are after that, which is 4. So then you add 4 zeros.
How did you get that?
How did I get that?
Yeah, the 4.
Because there's 4 different sections over here.
Oh, 4 sections to the right of it.
Yep.
Okay.
And then you go to your next one, which is 14. And there's 3 sections after, so you add 3 zeros. 17. You write down your 17, but you got 2 sections, so you have to add 2 zeros to the 17. 5, you got 1 section afterwards, which is 0, so you throw an extra 0. Then you've got your 3, and then you just add it all up. And I didn't do them. Somebody wanted to just times this real quick and tell me if I did it correctly. It's much easier to explain when you have colored pens or chalk. What's your question?
No. The 5 is supposed to be first.
Oh wait, this is supposed to be a 7. My bad. So it's a 7.
What? One's supposed to be 8.
Yeah.
This 5 and this 1.
That one.
It's supposed to be an 8.
Yeah.
How come? Let's look.
Well, right here this is supposed to be.
2 times 1 is 2.
There we go. Sorry. There's your answer.
2 and 6 is 8.
Yeah.
Okay.
Thank you.
Whether you go with the multiple lines or single lines with the number of intersection points there, which other model have we seen that this is like? I mean,
Would it be the Egyptian? Which one am I thinking of?
can anybody see anything in either of these that is like something that we've seen before?
Isn't the one with the grid?
I'm thinking of the area model. If this is 321, we have 300 out to here, 20. This isn't to scale, but and then oh yeah, and I've got the longer. So if this number is bigger, this should be longer, correct? Everybody know what I'm talking about here?
Yes.
So now I've got 400, 23. You following me? And 400 times 300 is 300 times 20 is 20 times 400 is 20 times 20, and 3 times 20 is 60. 20 times 1 is 20. 300 times 3 is 900. 400 times 1 is 400, and what do we got here, a 3? Did we do that right? If we put those all together, we should get the right answer. 3, and there's the 80, and can everybody see the different parts? And Where is the 8,000? Well, the 8,000 is right there. See it? Where is the 6,000? Right there. It's just each of these rectangles is one of my areas of intersection, which is why it works. Okay? Any other questions about the algorithms? Did everybody figure out the benefits of the Russian peasant? Yes? No?
No.
No benefits to it?
I don't know.
Takes too long?
How does it take me long?
What? Do you remember which one the Russian peasant is? Having and the doubling. The advantage is you only need to learn your multiplication facts of 2. How to double. 6s, 7s, 8s, all those things that plagued you, those nemesis. You don't need them. If you can half and double and add numbers, you can multiply anything. That's an advantage for some kids. Don't you think? Now, it does take up more room than a standard, traditional, compact method, but you don't need to know your 9s, your 5s, your 4s. You don't need to know anything but your 2s. Dividing and multiplying by 2. How to drop a remainder if there is one, right? And then you have to know how to add. There's an advantage. Any other advantages or disadvantages for the other ones that you learned?
Is that really an advantage?
Is it?
Every child is going to expect it. You know, their timetables to be able to pass.
That is the objective. Absolutely.
So, if they're learning how to do it that way, how are they going to learn how to do it?
She's asking a really good question. If our goal is to get them there, and a student's struggling, do we just say, oh, here's the Russian peasant, just do it that way?
I think you should start with Russian peasant, teach them multiples of 2, and then proceed forward.
What?
I mean, I guess you can do it without it. I mean, without knowing the table, like the multiplication table, as long as you can do the, the doubling, then you can, in theory, work around them all. But I guess the goal is you can memorize it so you don't have to.
We do want them to do the standard algorithm eventually. I guess the next question would be, if all we care about are answers, why not hand a kid a $1.99 calculator and say, multiply them, if that's all we care about? So what is our goal as we're teaching the mathematics?
Understand them to remember it.
There's structure, and we need them to understand that structure. Because even if they can run a calculator, if they don't know that when I multiply 30 by 200, or 30 something by 200 something, that I'm getting in the ballpark of what? 6 followed by 3 zeros, that it's 6,000 something, right? Then they're going to make mistakes even with a calculator, because they won't be able to estimate. So yeah, I'm not saying that it should replace. But, if I were a 6th grade teacher and a student had been unsuccessful 3rd, 4th, 5th, and now into the 6th, and I might show them this, that might be enough to get them excited about I'm successful with this, that they can move forward with some other things. I don't know. But why does it work? Have you thought about it? Why does the Russian peasant method work? Why do you only add the ones, so you cross out all the what? The ones that are even. Why do you add just the odds? Have you figured that out?
I've got one more question. Is this
Yeah.
at all, because when I looked up how to do it, One of the methods that it brought up, is it kind of like doing multiplication in a base too?
You're talking about the Russian peasant?
Because when I looked it up, it said the Russian method. I don't know if it's Russian method or the Russian peasant method, if that makes a difference. But what I came up with is that it converted it to base 2. and then
The
multiplied
Egyptian method is very closely related to base 2.
Because it had linked, it came up with the Egyptian one, and it said something about decomposition. And then the Egyptian method, it kind of went into that, and then it went into the Russian method.
All of those powers of 2 that you use, the 2, 4, 8, 16, and so on, all of those are base 2 related. Yeah. Well, we've got to cover some, this took a lot longer than I thought it would, but would everyone please grab their chips and try this problem, please?
Wait, can you just press down the bucket of chips?